All right, so let me give you the train wreck way to do this previous problem, which was r is, what, 3 cosine theta? Okay, so I want to convert from polar to rectangular, and I didn't notice to multiply both sides by r. It happens. We all have off days. So what I'm going to do is I'm going to take this piece of information and this piece of information, and I'm going to cram them in there. Right? I'm just going to take my conversion factors, and I'm going to stuff them in this thing. So I think what I'm going to get is the square root of x squared plus y squared is 3 cosine of tangent inverse of y over x. Oh God. Right? And at this point, you could maybe almost think about calling this a day. Right? Because now this is an equation that's like kind of in Cartesian, but this is super ugly compared to what we got when we did this the clever way. So there is some simplification we could do here. Do you all want to see it? So don't square both sides. Yeah. So I think primarily the scary thing is this guy right here. Right? That's like really fundamentally terrifying. Okay, so here's a trick for this. When you see nested trig functions, think about triangles. Okay? So here I have a tangent inverse of something, right? What category of object is that? What kind of thing is that?
It's an angle.
Yeah, that should be an angle, right? So someplace out in the world there's a triangle where there's this angle that's tangent inverse of y over x. What do I know about this triangle? Right? It's a right triangle because I'm playing trig games in it. What else? What do you know about the tangent of this particular angle here? The tangent's the opposite over the adjacent, and it's also y over x. Okay, see that? So I'm just going to make some wild assumption that the opposite side is y and the adjacent side is x. You guys see that? Like that's one way for this tangent to work. There's some similar triangle in this. You guys cool with that? How about, what's the hypotenuse now?
That would be the cosine, or x times the cosine of that.
Yeah, but that's horrible. So let's figure out the hypotenuse a different way. So what's the other tool you have?
The Pythagorean theorem.
Pythagorean theorem. So this hypotenuse is the square root of what? X squared plus y squared? Okay, so what's the cosine of this annoying angle? Cosine's the
X over y.
adjacent over the hypotenuse, right?
Yeah, so
Okay, so I can replace that stuff over there with, let's see, 3, right? The 3. And then the cosine is
X over x squared.
x over the square root of x squared plus y squared.
Multiply both sides.
And then over here, I still have the square root of x squared plus y squared. And then we could what?
multiply by
Multiply both sides by the square root of x squared plus y squared.
which gives you
Which will give you
x squared plus y squared equals
x
3x.
squared plus y squared
Equals 3x.
is 3x,
So we got 4.
which is what we got before, so awesome.
Ew.
Cool?
It's a bit icky.
Yeah, so this way was icky, right?
I need a shower.
And the reason it was icky was that I didn't notice I could multiply everything by r, and so I had to sort out this horrible business. You guys see that? I could have maybe noticed something better if I had said, okay, so over here, x is cosine theta times r, right? So cosine theta is x over r. right? I could have put that in there. And then I would have had r's and x's, which is weird.
Yeah.
But this whole business is r, right? This is
Yeah.
r squared. That would have helped, maybe.
Yeah.
Cool. So there's multiple ways to do these. I would try something, like primarily try something, and if it seems horrible, go back and think about what else you could have tried. But trying something is the big step.